Hello everyone, my name is FEBA and today we are going to learn some basics about production system in AI. So, in this video we are going to cover the introduction, components of production system, features of production system, classes of production system, advantages and disadvantages with example, and last but not least, requirements of good control strategies. So, now let's get started. What is production system? Production system is an artificial intelligence framework developed for solution of any problem. In production system, information is represented in the form of rules. It can be characterized as a sort of intellectual design. Production system represents knowledge and action as well. Production system, also called production rule system, is a form of computer program used to provide some form of artificial intelligence based primarily on a set of rules about behavior. These rules are a basic presentation found helpful in expert systems, automated planning and action selection. This provides the mechanism necessary to execute predictions in order to achieve the goal state for the system. Now let's move on to the components of the production system. There are four components in production system. The first one is global database. It is the primary data structure used by the system in AI. Second one is set of production rules. The rules and regulations that govern the global database. Every production rule consists of a prerequisite or precondition that the global database either meets or not. If the precondition is met, the rule is often applied. The third one is control system or search strategy. The control system is the decision maker to choose the rule which should be applied and stops the processing when a termination condition on the database is met. The control system is also responsible for handling the conflicts if multiple rules are to be fired at the same time. The fourth point is a rule firing module. It checks the appropriateness of rule by coordinating the present status with the left-hand side of the rule and finds the fitting guideline from the database of rules. In simple words, it is the computational system that executes the control strategy and applies the rules. Now let's move to the features of production system. There are four major features. The first one is simplicity. Each sentence in the production system is unique because they use if-then structure. This component improves the comprehensibility of production rules and communication between different parts of a single program. The second point is modularity. This implies the production rule code the information accessible in discrete pieces. Data can be treated as an assortment of independent realities which might be included or erased from the framework with basically no deleterious reaction. The third point is modifiability. This implies the facility of modifying rules. It permits the improvement of production rules in a skeletal structure first, and afterward it is exact to suit a specific application. The last but not least, knowledge intensive. The knowledge base is the production framework stores pure information. This part doesn't contain any sort of control or programming data. Every production rule is typically composed as an English sentence. The very structure of the representation solves the problems of semantics. Now let's move to the classes of production system. There are four classes of production system. The first one is monotonic production system. It is the type of production system in which when one rule is applied, it does not prevent the later application of another rule. The second class of production system is partially commutative production system. It's a productive system where a grouping of rules is utilized to transform one state into another. Any permissible permutation of those rules also delivers the same results. The third point is non-monotonic production system. These are production systems that are important from an implementation standpoint. They are used where it is not needed to identify the previous states when it is found that a wrong path was followed. This production system helps increase efficiency as it does not keep a record of the changes made in such processes. The fourth class of production system is commutative system. Such production systems are beneficial for problems in which the changes can be reversed and the order of operation is not significant as a chemical analysis of substance. In such systems, it is important to make the correct decisions initially as the order in which operations are performed as crucial. Now let's see what are the advantages of production system. The first advantage is the system is profoundly modular on the grounds that individual rules can be included, evacuated or modified freely. That means the system can be modified easily as each rule is independent of one another. Rules can be removed, added or changed independently. The second advantage is partition of knowledge and control recognized act cycle. That means knowledge base and the controls are separate in this. The third advantage is the system utilizes design coordinated control which is more adaptable than algorithmic control. That means the system pattern directed control used by the system is more flexible than algorithmic control. The fourth advantage is a decent method to show the state-driven nature of intelligent machines. That means an excellent method to model the state-driven nature of intelligent machines. The fifth advantage is very accommodating in ongoing domain and applications. That means it's handy in real-time environment. The sixth advantage is a characteristic planning into state space search information or object driven. That means a data driven mapping onto state space research. Now let's see what are the disadvantages of production system. The first disadvantage is the opacity is generated because of less prioritization of rules, more priority to a rule that has less opacity. The second disadvantage is the rules in a production system should not have any type of conflict operations. The third disadvantage is during execution of a program, several rules may active. A well-devised control strategy reduces this problem. The fourth disadvantage is rule-based production systems do not store the results of the problem for future use. Here is an example of production system. We have two jugs of capacity with 5 liter and 3 liter and a tap with endless supply of water. The objective is to obtain 4 liter exactly in the 5 liter jug with the minimum steps possible. In this production system, there are 8 steps for this particular example. So, the first step is fill the 5 liter jug from tap. The second is empty the 5 liter jug. Fill the 3 liter jug from the tap. The fourth is empty the 3 liter jug. Fifth, empty the 3 liter jug to 5 liter. Sixth, empty the 5 liter jug to 3 liter. Seventh, pour the water from 3 liter to 5 liter jug. Eighth, pour the water from 5 liter to 3 liter but do not empty the jug. After getting the production system steps, now we have to find out the solutions. So, here are two solutions which fit in the best. That there may be often other solutions. These are the shortest and the first sequence is chosen as it has the minimum number of steps. That is the first sequence is 1, 8, 4, 6, 1, 8. This is the first sequence of answer or the solution we have chosen. The other sequence is 3, 5, 3, 7, 2, 5, 3, 7. So, after choosing the first sequence, we can see that the solution is step 1, fill the 5 liter jug from tap. Step 8, pour water from 5 liter to 3 liter, do not empty. Now move to step 4, that is empty the 3-liter jug. Then move to step 6, that is empty the 5-liter jug to 3-liter jug. Now we have to repeat the first and the 8th step, that is fill the 5-liter jug from tap. And the last step is step 8, that is pour water from 5-liter to 3-liter. Do not empty the jug. Now let's move to control strategy. This is the main component of a production system. Control strategy in artificial intelligence situation is a method or strategy informs us regarding which rule must be applied, straight away looking forward for the solution of a problem inside problem space. It encourages us to choose which rule needs to apply next without stalling out any time. So it helps us to decide which rule has to be applied next time without getting stuck at any point. These rules decide the way we approach the problem and how quickly it is solved, and even whether a problem is finally solved. Control strategy helps to find the solution when there is more than one rule or fewer rules for finding the solution at each point in problem space. A good control strategy has two main requirements, which we are going to see in the next slide. The important component of a production system is its control strategy. So, we should choose good control strategies. For choosing a good control strategy, there are three requirements. The first one is it should cause motion. The second, it should be systematic. And the third is it should be efficient. Now let's see these requirements in details. First one, control strategy should cause motion. Each rule or strategy applied should cause the motion, because if there will be no motion, then such control strategy will never lead to a solution. Motion states about the change of state, and if a state will not change, then there be no movement from an initial state and we could never solve the problem. And the second requirement is control strategy should be systematic. Though the strategy applied should create the motion, but if do not follow some systematic strategy, then we are likely to reach the same state number of times before reaching the solution, which increases the number of steps. Taking care of only first strategy, we may go through particular useless sequences of operators several times. Control strategy should be systematic implies a need for global motion as well as for local motion. In this, there are some steps, that is, first search method is used is breadth first search. The second used is depth first search. Here we have other control strategy which are widely used are generate and test, breadth first search, depth first search, hill climbing, best first search, problem reduction, and many more. And the final requirement of a good control strategy is it must be efficient so as to locate a good response. That means it should be efficient to find the best. Thank you everyone for listening to me very patiently.